Microphone working? Looks like it. Cool. Make sure this is down. Alrighty. Hey, everybody. Thanks for joining me today. My name is Brian Morrison. I am on the developer education team here at PlanetScale. Last week, we released the serverless driver for JavaScript, which is a way to, it's a fetch compatible library for JavaScript applications that allows you to circumvent some of the restrictions that are present in some cloud providers where you can't make arbitrary outbound TCP connections from things like edge functions, Cloudflare workers, things like that. This kind of circumvents that and allows our users to be able to build things on top of those different environments. So today I'm going to be demonstrating how you can use the serverless driver for JavaScript, specifically building some AWS Lambda functions. We're going to start by creating a simple Lambda function that just queries some data from a database. We're actually going to set up a database before that, and I'll show you where you can toggle the feature on. But then once we test that up in AWS, we're going to extend that and create a serverless API using API Gateway in AWS. And what that's going to let me demonstrate is how you can use all the common data operations that you would normally see inside of working with a database. This would be things like selecting data, inserting data, updating and deleting it. We're going to map those to common HTTP methods like get, post, put, and delete. And then finally, all the way at the end, once we finish all this, we're actually going to be dropping a link inside of the chat, which is going to let the first 5 people who access and check out from that link get a free database hat provided by PlanetScale. So with that, let's go ahead and hop in and get started. Coffee and Code Guy, welcome to the stream. Thanks for stopping by. Before I even start coding, I wanted to take a moment and show you what this hat looks like. So this is from our Twitter. I've heard a lot of good things. It's a good hat. It's a great hat. You're going to want the hat. So stick around for that. But okay, with that, let's go ahead and start by creating the database. So what I have here on screen is the first thing that you're going to see when you create a PlanetScale account. I like starting from the ground level so people have a good understanding of how to work with the platform in general. We're going to be working with a concept that I like to build things with on PlanetScale, simulating something of a travel agency. Typically, I would have more tables, but for the sake of this demonstration, we're essentially going to create one table called hotels. But still, let's create a new database and call this TravelDB. So travel_DB. We could leave the region as the default, and we will click Create Database. So now once you get past here, you'll see the database is initializing. We need to wait here for a few moments. It only takes a minute or so for this to complete initializing, but once that's done, we'll be able to turn on the feature. As it stands right now, the serverless driver is still technically in beta, so it is something that needs to be enabled per database on the database level. And when you enable this, it's going to let you create different kinds of connection strings, different kinds of credentials, which use some of these different endpoints that we have available to use the driver. So we're just going to wait here for a moment and wait for this to finish. Okay, so that's done. Let's go ahead and turn that feature on. So if I go to Settings, and I go to Beta Features, there's a new option here, PlanetScale Serverless Driver for JavaScript. Go ahead and click Enroll if you're following along. So now that that's enabled, you can see in the lower left-hand corner there should have been a message pop up. Let's go ahead and go to our branches and navigate to our main branch. Now, going to console, we should be able to get a web console where we can execute commands directly against the database. I have this script that I put together, which will let us create this table. And just for the record, anything that we write here today is eventually going to be published as open source on GitHub. So if you're not already doing so, follow us on Twitter at PlanetScale Data. Yeah, I should know that. At PlanetScale Data. And that will, we'll drop a link when that goes live. Okay, so let's go ahead and copy this in here. Copy the create table. I'm going to go ahead and paste that inside the console here. So we're going to create 4 fields. The first is the ID. Let me zoom in here a little bit. It might be able to be easier to see. So the first thing we're going to do is create the table, 4 fields. There's an ID column, which is going to be an auto-incrementing integer. We're going to have a name that'll allow 50 characters as a string, an address that will allow 50 characters, and then finally a stars, which could simulate something like the rating on a hotel. So you go to a travel website, you typically see ratings on hotels. We're going to force set it. Typically you don't do that, but that's what we're going to do here. So I'm going to go ahead and click enter on my keyboard, and that's going to create the table. Okay, and then let's insert these 2 rows here. So we're going to populate this with a little bit of data. I'll paste this in here and click enter. You can see that's completed. And then if I do a select star, from hotels, which is the name of the table we created, and hit enter, we should see these 2 rows pop up, and these correspond to this insert statement that we put in here. Now, the next thing we need to do is generate a connection string to allow allow the code to access the database. So this is something, what I'm going to do is I'm going to show you how to create the connection string, and then you don't ever want to share your connection details public. So what I'm going to do after I do that is I'm going to delete those and then generate a private pair that I'm going to use for later. So I'm going to click connect, and you can see if this is the first time I'm clicking connect in that button, I'm going to get a username and password. If you change from general to this new entry, this @PlanetScale database, this will show you the environment variables that you need to use in order to connect to the database, as well as a sample JavaScript file that shows you how to do some very basic things with it. So I am going to, like I said, I'm going to switch out of here. So this way I can hide my screen a little bit. Okay, I'm going to delete this. First, I'm going to delete this password, then I'm going to create a new one. So bear with me for just a moment here. Okay, and then I'm going through that same exact process, and I'm going to create a brand new connection string. So I'm not doing anything that we haven't already done yet. I'm going to save that off into my notes, and then we will be done specifically with the database portion of this. So now let's get into writing some code. Switch back here, and I'm logged into AWS. So we're going to create a Lambda function. So if you're following along and you're inside of AWS and don't have some of these recently visited entries here, you can actually find Lambda by using the global search and typing in Lambda. Select that from the list of entries there. I'll zoom in here just a little bit too. And let's click on create function. We don't have a function created yet, but we're going to get here. We will say, so I'm going to name the function serverless driver demo. We want the runtime to be Node.js 16. Architecture can be x86 64. And then everything else besides the name can kind of be left as default. So I'll go ahead and click create function. This takes a moment for it to just kind of initialize everything on the back end and AWS's side. Okay, so our serverless function's created. Now, there are two ways that you can build Lambda functions. You can either code directly in here if you're just doing some basic things with JavaScript, but since we need to install some packages using NPM, we're actually going to do it local on the computer. So I'm using VS Code, but basically using a terminal in any IDE is going to be sufficient for following along. I'm going to open up a terminal, and let's expand this out all the way. And I'm going to go ahead and initialize a new library. So npm init-y is going to create that. It's going to create the basic package.json folder but with accepting all the defaults, which is fine for what we're doing here. And then I'm going to run npm install @PlanetScale /database, like that, and hit enter. And this is going to install that serverless driver. I'm Matt Davidson. Thanks for joining. Thanks for hopping in the chat. Hope you're doing well today. Okay, so we've installed that package. Now, because AWS Lambda only supports up to Node version 16, they didn't implement native fetch until Node 18. So what we need to do is use another fetch compatible package in order to kind of use with the serverless driver. So what I'm going to do is I'm actually going to clear the screen so we can get this closer to the top. And I'm going to do an npm install node-fetch. Okay, and because the serverless driver package uses a module ES6 or ES7 import style, we actually need to go into package.json, and we're going to change this. We're going to add the type keyword in here, and then we're going to set this to module, which is going to let us use that newer ES7 style imports. Hurt Wolf, how you doing today? Thanks for joining the stream. All right, we're going to create a new file here, index.js, which is going to hold all of our code, essentially. And then I'm going to import, open brackets, and then we're going to import the connect function from @PlanetScale database. And then we're also going to import fetch from node fetch, like that, okay? Now, if you've ever created Lambda functions before using JavaScript, it follows a pretty common pattern. So we have to export a top-level function called handler, and then it's going to pass in one parameter, which is going to be event. So I'm going to create that function now. Exports. We're going to export async. This has got to be an asynchronous function. handler, and then we'll pass in event here. So this is the structure of pretty much any Lambda function. Now let's first set up the connection configuration. So I'm going to create a new parameter or a new variable here called config, and we're going to set this to an object. The first thing we have to pass in is that fetch library. So we can just type in fetch with a comma and then hit enter, and this is going to tell the serverless driver to use node fetch as opposed to attempting to use the native fetch, which is not actually available in AWS Lambda yet. So the next thing we need to do is set the host to process.env.database hostname. This corresponds to those environment variables that we saw when we generated the connection string on PlanetScale side. So, and then we also need to use username is going to be process.env.database username. And then password, word, if I could spell, is going to be process.env. And I'm sure you guessed it, database underscore password. Okay, hopefully I didn't typo any of that stuff there. And then the next thing we need to do is we need to create that connection. There's a connection object that you can pass around within your application that lets you execute queries. So we're going to create another variable called connection. I'm just going to use con for short, C-O-N-N, equals await connect, and then we'll pass in our config options here. So at this point, this is the point in which our database is connected, and then we can execute a query. So any queries that are executed using this driver are output to an object that you can use to either see stats about the execution, such as how long it ran. You can also get your rows, obviously, and then in situations where we're inserting data, you can get the ID of the actual data that was inserted. So let's go ahead and cast this to results equals await connection.execute, and then we're just going to pass in select star from hotels. So this is going to select all of the data from the hotels table that we just created in the previous section. So, and then the last thing we're going to do is we're going to console.log those results, so we can see what that object looks like in memory. Excuse me, there, lost it. Okay, so this is the first step in creating this entire function, which is going to eventually be set up for an API and showing off all of the different things we can do with this. So in order to get this up into AWS, I'm actually going to select this all from the file system. I'm using Windows. You can do this on a Mac, though. I think it's right-click and archive. But on Windows, I'm going to right-click and send to a compressed zip folder. I'm just going to name this FN, shorthand for function. Now, if I go back into AWS, and then I'm going to, inside a Lambda function, which is still open, there is the code. There's a set of tabs about halfway down the page in the second section. I'm going to make sure that I'm on the code tab, and then click upload from, and then zip file. We're going to browse to the file that we just created, that zip folder, and I'm going to select it and click save. So once you save and the function's actually been uploaded, you'll notice inside of the code editor that's available inside of the web, it's been updated to match the code that we wrote inside of VS Code. Now we're almost there for getting the basics portion of our function set up. Now, since we are going to be using environment variables, the database hostname, username, and password, in order to create that connection object, we need to set those environment variables up inside of Lambda. So you can do that in the configuration tab, and then under environment variables, which you can see I already have selected. I'm going to click edit, and then add 3 environment variables. And I'm not, once again, going to show all of this on screen, but if you recall from the PlanetScale side of things, we had a username, a password, and a host. And let's see here. And we're going to paste those variables in here. So I'm going to once again switch back to my handling secret screen, so you can't see this. And then I'm just going to paste in those connection details. So we got to grab the host, we have to grab the username, and we have to grab the password. And I'm going to save that and navigate away from that screen so y'all can't see it. Iha D Cornu, thanks for following. Matt, thanks for following. Appreciate it. Okay, so this is pretty much set up and ready for us to run. Now, in order to test this, we'll click test. We need to create a new what's called event inside of this to test it. We can leave most of this inside of the test event as default. You just have to make sure to give it a name. I'm just going to name it test just to give it something to satisfy AWS, and then click save on the bottom. Now, if I run this, provided everything was done properly, we click test. We do have something wrong. What's going on here? Address. Let's try and run this one more time. I ran into this when I was demoing this for myself earlier, and we still had this issue. Okay, I actually need so the reason why, if you look inside of this error message, it's showing that undefined / some PlanetScale path is not found. That's probably because it's not reading in our environment variables properly. So I gotta switch back to handling secrets so I can make sure I added those in there the right way. Database underscore host name. Is it just database underscore host? I think it was database underscore host. I somehow feel like I fudged that just a bit. Yeah, so inside of the actual output of the PlanetScale is database underscore host. I can actually switch this back so I can walk through this, but you can see for host, I mistakenly put host name. Doesn't really matter. I'm trying to use the defaults that come out of PlanetScale, but realistically, as long as your environment variable names match, that's the important part. Mine did not, which is why this didn't pass. At least that's what the theory we're working off of right now. So I'm going to go ahead and run this test one more time after updating that. And we can see the response was null because we're not using the HTTP integration. But if I scroll down here and I look at, this is the object that was actually, this is that results object. So taking a look inside of here, we can see headers is the name of the columns that are available to us. We're also passing back types. So you can see the ID is a unsigned 32-bit integer, name and address are strings, varchars, and then your stars is a float 32. Here's our rows. So results.rows would be able to get us this array of data as it comes through. Rows affected is going to be the number of, if you're doing something like a data modification query, rows affected is going to show that data. If you're inserting data, there's that insert ID I mentioned earlier. Error is an object. We'll see how to do some error handling as we're building this thing out. Size is the number of rows you have. Here's the statement, and then here's the number of milliseconds in which it took to query the data. Ahmed Davidson asks, is Lambda the only way to get this working on AWS, or are there other options? Basically, anything that supports JavaScript will be able to run this. We actually have a demo in the docs. Let's see here. I will post this in the chat here, but there is a Node.js example that we built that does not use any kind of serverless functions. You can actually run this right within Express too, which is what this is. Hey Taylor, thanks for joining. Orware, thanks for sending that example. Appreciate it. Okay, cool. So let's move on. I'll let Taylor and Matt kind of chat in the chat. All right, so back up inside of AWS. So we've got our basic select function working. Now let's go ahead and extend this, and we're going to build out three more ways that we can handle these the requests that come in. So I guess it'd be four. We're going to create a get function. We're going to create a post, a put, and delete that map to different types of data modification queries that we can do as well. So I'm going to head back into VS Code. And what I'm going to do is there are different ways that you can set up Lambda functions. You can set it up in such a way that you have one function for one HTTP method, but I find that to be a little bit overkill. So I like using a switch statement to map the actions from HTTP or the method into separate functions instead. So what I'm going to do is I'm going to get rid of some of this stuff here. I'll just add some lines because I'm going to need to repurpose some of that. We're going to create a switch, and we're going to switch off of event.requestContext .htp.method, which will get us the method from this event object. This event object is going to be active when we're passing data into it using the API. So we can use that to figure out what method is actually being executed. So let's just handle get right now. So I'm going to handle get, and then we're going to return await. I'm going to create a get function, and we're going to pass in both of the connection and the event into that get function. Nikki T online, thanks for the follow. Really appreciate it. And then the last thing we're going to do is we're going to have a default here. And in the default, I'm going to return an object. I'm going to say a status code of 404, which is not found. So basically, if somebody tries to hit this endpoint and we're not handling that specific method, we're going to return a 404. Okay, so let's create a new function, async function get. Let's get some more space here. We'll put this more to the top. Async function get, and we're going to handle the connection, and then we're going to handle the event. So from here, we can actually move our results down here, results object, because we're going to end up returning that. We can get rid of console.log because we're not going to be logging out to the console anymore. And then we're going to return another object from here. So we have our results, which are going to be passed into this results object. We're going to return a status code of 200 for found. Since we're passing back JSON, we have to set the headers properly. So we're going to create a headers object, and we're going to set content type to application, if I can spell, application, JSON. Okay, and then the last thing we're going to do is we're going to set the body to a stringified version, json.stringify, of results.rows. So this is going to pass back an array in the response body of our request that we make. Okay, so now that that is set up, let's go ahead. I think I got that all lined up the way it's supposed to. Let's go ahead and zip this back up and then re-upload it up into AWS, and then we'll set up API Gateway. So I'm going to delete the old fn.zip thing that we created. We're going to right-click this again, send to compressed folder, and we'll rename that to fn for consistency. Now let's head back into AWS, and let's re-upload this zip file that we created. I'm going to upload that function.zip file and click Save. Cheaper options, shop around with hosts. Currently don't have you. I'm sorry, I'm reading through the chat right now. So Matt says, just wondering for cheaper options, shop around with the hosts. Currently don't have a VPS. Yeah, Taylor, like Taylor said, it's platform agnostic. So you can basically use this with anything that supports Node or JavaScript. So, okay. Let's go ahead and try it. Let's go ahead and configure API Gateway and then set this all up. So I'm going to type in API Gateway in the top, or just API, and get to API Gateway. We're going to open this in a new tab so we can flip back and forth here a little bit. And then let's go ahead and create an API. There are a bunch of different API options you can create in here. You want to select the first one, HTTP API, as it's the simplest one to start working with. And then we're going to click Build. Okay, I'm going to add an integration. And we're actually going to integrate with a Lambda function. And then we're going to select our function that we just created, which was serverless driver demo. Version can be 2.0. That's what we're expecting to work with. And let's give this a name. Let's do serverless driver demo API. It's not to confuse with the one I created earlier when I was testing this. So we'll have to look out for that. As far as resource path, let's change this to hotels. You can see it automatically tried to pull the name of the function and made that the resource path. You'll also have options here to select specific actions, but we're not gonna change that. We're gonna leave that as any, because we want our single function to be able to handle any method that's coming through. Go ahead and click Next. Define stages. We can just use this default. API Gateway supports multiple stages if you wanted to have different environments to test with, but it's kind of beyond the scope of this demo here. So I'll click Next, and then click Create after reviewing everything that AWS is telling me I'm going to create. Okay, so our API was created, and you'll notice that there is an invoke URL in this second section under Stages. So I'm going to copy this invoke URL. Let's go back into VS Code. I'm going to create a new file called tests.htp. And I'm specifically using a plugin called the VS Code REST Client plugin for VS Code. Yeah, REST Client plugin for VS Code. The reason I like this plugin over other third-party tools in order to test APIs is you can actually save your request in just a standard text file that gets saved alongside the repo. So I recommend it, but if you're comfortable using things like Postman or any other third-party API testing tools, they work just the same. So let's go ahead and type git, and then we'll paste in that URL. And then if you recall, we set the route to hotels, just like that. And then above this GET request that I typed, there is a send request link that actually just shows up. So I'm going to click on that, and it's going to execute that request, and I get an error right off the gate. Cool. We get to do some live debugging, so I got to figure out what I might have possibly done wrong. All right, let's go back in here. So since we got this 500 internal server error, we know that it was something was handled. I know what it was actually off the top of my head. I never fixed that host name in my code, so that's probably what the issue is. You can, if you ever wanted to get into debugging for Lambda functions, you can actually go to CloudWatch, which is where all these errors are logged out to by default. So just to demonstrate that, I'll go ahead and open CloudWatch, and we'll wait for this to load. I'm going to go into log groups, and then once this loads, I'm going to go into serverless driver demo, which is the name of the function we created. You'll see that there will be multiple entries here because every time that execution happens, I think it rolls over every 30 seconds if I remember correctly, but it groups a lot of these log entries together. So I'm going to select the latest one, and if I drop this down, we're going to get that same undefined error message, and that's because if I look at my code, I never fixed hostname in here. So I'm going to fix it here so we don't run into that same issue again. And then I'm going to go back into Lambda, and since we can just use the in-browser IDE, Let's delete hostname from that, save it again, and deploy it. Okay, so now that that's updated, let's go ahead and try and run this again. Send request. There we go. We got a 200 response. And you can see this is the JSON that's being sent back from Lambda, which is actually querying our database in PlanetScale. So cool. We got the first of our 4 functions set up, which is a get. Now let's go ahead and set up a post function, which is which is typically used for adding data into some kind of data store or database. So I'm going to copy this again. I'll copy this again. Copy this down to a new line, so we have another switch case, and we're going to set this to post. We're also going to change the name of the function to post because we're going to create a new function called post. So I'm going to create that new function, async function post. Now let's pass in our connection, our event. Now we need to pull data out of the request body. So the way that we would do this is I'm going to extract those fields here. So we'll do name, address, and stars, because those, besides the ID field, those are the 3 that we typically are going to want to update. The ID field shouldn't not be updated because that's how that record's identified. And if we set this equal to json.stringify or json.parse, event.body. So the body object of the event is it's actually a string, so we need to parse that string out into something that we can actually work with in our code. So I'll go ahead and do that, and now I'm going to craft that query. So I'm going to do let res, let's actually do const res. Let's use res just to shorten it up. Equals await connection.execute. And then there are actually 2 different ways that you can pass parameters into a query string, which I'll cover the first one, and then we'll use my preferred method. So the first way we could do this is we can do insert into hotels. We open a parens, and we're going to say name, address, and stars, because those are the 3 columns we want to update. And we're going to pass our values in now. Let's go ahead and scroll up a little bit on this so it's a little towards the top. Now, the first way that we can do this is we can use question marks. So question mark, question mark, question mark, because those are the parameters that we want to work with. And if I pass in an array of values here, so you can see this execute takes in 2 parameters here. We have the actual query string, which is the same as we did up here where we're actually using a select query. We just don't have to pass in any kind of parameters. And then the second parameter is where you would pass in your actual query parameters. So the first way of doing this is using an array, and we could do name star or name address stars. And what the driver will do is it will update the query string before it sends it to PlanetScale and replace the question marks with these values in the order in which they were populated in the array. So this will eventually end up with name, address, and stars. That's one way to do it. The other way you can do is you can actually use named parameters with a colon in front of them. So if I do colon name, colon address, and then colon stars, let's add spaces in here to make the query look a little bit nicer. And then instead of passing an array, we're going to pass an object. Let's see, let me fix the object down here. Okay, so what this will do is this will replace these specific entries based on the name of the parameter that's being passed in. So instead of doing it in a specific order, this is a little more explicit. Either way works and does exactly the same thing. It just depends on how you prefer writing your code. Okay, so the next thing we're going to do is we're going to get into a little bit of error handling. If for whatever case there's an issue with this query, the way that we can handle the serverless driver for JavaScript does not throw when an error occurs within, say, like a data type's not passed in properly, or the query is not assigned properly, or it's not structured properly, right? So there's that error object that's part of the response that comes back from the driver. We can use that to determine whether there is or is not an error. So if I check that, I can do if res.error. So if that has any value in there, then we know that something happened in the code that we need to go back and fix. So I'm going to, instead of returning a status code of 200, I'm going to return a status code of 500 for internal server error. We still need to set the headers, and we'll still need to set the content type. And that's going to be application /JavaScript. I didn't get a return here. Return. We got to return all this stuff. I can't just put this stuff right inside of an if statement. So we're status code, headers, and then the last thing we need to do is, again, the body. And then that error object is an object. It's not a string. It's not a code. So we can extract some information from that. So we can pass in json.stringify. and then pass in res.error, which will show what exactly went wrong. It doesn't log the entire output, so you might want to take some additional measures to log some of the stuff that happens, like the actual query that's crafted. But this will be sufficient in at least telling the caller that something went wrong with the query specifically. Okay, so that handles if there is an error. Now, if there is not an error, we can return a status code of 200. And I'm going to copy actually this just to avoid myself having to retype all that over and over again. And then we can either return just an empty response with 200, but I prefer returning the actual ID of the object that was created in the database. So I'm going to stringify a new object here, and I'm going to pass the ID to res.insert ID. Now this will be a string. So we need to do in order to turn this into a number is just cast it to a number by passing it to that type like this. So now this will convert any ID of the object that was created using this insert statement into a number and pass it back to the caller so we can see what the ID of of the object that was created. Okay, I think we're good on this one. Just scan this, make sure I ain't got any obvious errors. Of course, we might run into a circumstance where we need to debug again. I'm going to go ahead and save that, and let's go ahead and zip this back up. We fixed our host. I'm not worried about that again. I'm going to delete our zip file here, right-click all, send to compressed zip folder, and let's name that to FN. Now, let's upload the zip file again. Hit save, and let's test this out. Now, we don't actually have to make any modifications to API Gateway at this point, since we mapped any method into this function. So let's go ahead and try and create a hotel. Anyone in chat? Anyone want to toss out a hotel? Maybe I can grab the address and rating for. Do a little interactive live streaming here. I'll let that simmer for a moment while I'm setting this up. Okay, in VS Code, I'm gonna put in 3 hash marks, which to the VS Code REST client plugin will denote that this is going to be a new request for typing on the following line. So let's go ahead and put post, and then I'm going to copy the URL, so I'm not typing this long guy here. Okay, Matt Davidson says, Orca Sun Life Oludinis? I can't even say that. I apologize if I butchered that. Let's look it up. I'll find the address, and we'll do that. Okay, so post inside of in the plugin, you can also type in the name of your headers directly below this. So I'm going to set the content type to application JSON. And then we need to add an extra space down, and then we can open up some JSON and pass the body in. So we'll do name, and then we'll do star address, and then we'll do stars, because these are the 3 objects we're looking to update for, or actually looking to create. We're still in the create portion. Okay, let's see. Let's look this up. Orca, Sun Life, Oku. Oh, I saw it. Here we go. We got an address. It's gonna be interesting. Some live handling of special characters in the code. So, all right, let's copy the name. We'll come back here, do name, and then we'll copy the address. Paste that in, and then 4.2. Let's do 4.2. 4.2 for stars. Okay, let's save that and click send request. Ah, see, we got another internal server error. Data too long. Oh, see, I made a mistake, but this is probably more than 50 characters. Let's go ahead and trim some of this stuff off just to make sure we don't run into that. I kind of went by that fast. I'll pull it back up just to show you what I saw. I'm gonna close the tab. All right, let's execute it again. So this is exactly how we handled an error here. So you can see inside of the error object, we have a message, and then we have an invalid argument. So our message here does show the query that's actually executed, but if you kind of scan through this a little bit, we could see data too long for column address at row 1. So that was how I knew that the data that I passed in was too much for the database to handle, so to speak. That was a kind of a mistake on my part because I didn't make the field long enough and kind of ask the audience for help. So yeah, and then you also have a code here, which if you're building error handling logic around this, the code is probably one of the things you'd want to take a look at and use in order to determine which response you'd want to send back to the caller. Okay, so that's there. Let's go ahead and trim this down. That was great. Thanks for the suggestion. That actually worked out really well. And let's go ahead and send request. And we got a 200 OK status and the ID of 3 that was created on the way back. Now I'm going to close this and I'm going to run the GET request again. And you can see now we have 3 hotels. We have the first 2 that was created when we first created the database. And then we have that third one that was just created now. So thank you, Matt Davidson. I appreciate that. All right, so now we now see that the post is working. I'm going to close this out. And now we're going to actually do both the put and the delete in one shot, because we've seen how we can modify the query, and we've seen how we can just use a query without any kind of data that's being passed in. Or I'm sorry, we learned how we can pass data to a query through parameters. Probably a better way of saying that. So let's go ahead and go back up inside of our switch statement here. I'm going to paste in this in twice. So we will key off of put, and then we will key off of delete. And as you imagine, for this function name, we're going to name this put. And then we can't actually use delete because it's a keyword in JavaScript, but we can use del, which we can create a function based off of. Okay, so I'm going to create a new function for put. So async, let's go ahead and get some more room here. Async function put connection and event, like that. And we know we're going to need to grab these 3 values off of the body as well. So I'm going to copy this and bring this down here. Now, one of the things that you typically use when setting up an API is the route would be something like put / hotels / some ID like that. So we're also going to need to update the code and update the API gateway configuration to support this setup. So in the code, it's actually relatively simple. Instead of pulling from the event body, we're instead going to pull from event.path parameters, which is going to be where that ID lives. When we configure this in API gateway, we're going to set it up so this way, this will be a named parameter of ID just like this. Okay, so now let's set up our query that's being executed. I'm going to scroll down a little bit so we can get this closer to the top. Const results equals await. See, connection.execute, and then we'll pass in our update statement. So update hotels. We're going to set name equals to name. Address is equal to :address for those named parameters, and stars are going to be equal to stars. And then we're going to put where ID is equal to ID, because we only want to update. If you don't pass in the where clause, it will actually update every single row in the database. So you want to make sure that where is set up. Hey, James, thanks for dropping by. Appreciate it, man. Hope you're doing well. Okay, so now we need to pass in our parameters here. So we'll do name, address, stars, and ID, just like that. So this is our update statement. Make sure that's all good. Execute. Okay, so that is where the actual query will be executed. I'm going to copy back in our error logic here, because we don't really need to change anything about that. That can stay just the same. And then I'm also going to, instead of returning any data in this situation, we're going to return status code of 200. And then this should basically be our put function. And then instead of creating a delete function, because this will be a little easier, let's go ahead and copy and paste this down here. We'll name this to delete, and then let's clean up the stuff we know we don't need. So we don't need any of these parameters because we're not passing in anything to the body. So we can get rid of all those from our object. Okay, and then we can get rid of all of this stuff here, and we'll do delete from hotels where ID is equal to the ID. And that should pretty much be our delete function. So we have all 4 of our functions created. James, I am creating, where we're actually demonstrating the new PlanetScale serverless driver for JavaScript, which allows developers to write edge functions that work with PlanetScale. And I'm building an example API in AWS using Lambda and API Gateway to demonstrate some of this. Okay, so we've got all of our functions created, I think. Let's go ahead and zip this up and put this up into AWS, and then we'll finish off the section of configuring API Gateway. So we'll send to compressed folder. Name that. Nice, new setup looks good. Yeah, thanks. We put some work into it, so I'm pretty happy with it. Thank you. Okay, so that is done there. Let's go ahead and go back in here, upload this. So we're uploading a new version of our function, which has all of the code to handle those other 2 parameters. Now, before we can actually test this using VS Code, using that plugin, we actually have to create a new route inside of API Gateway. So you can see when we created this, we have /hotels and /any. Now what I'm going to do is I'm going to create a new route, and we're going to name this to hotels / and then open curly bracket and then ID, which is where that named parameter comes from. Inside of the URL, that is, inside of the path params. So I'll click create here, and you'll notice now there's an extra slash here with this any underneath it, but there's no integration attached. So if I click on that and click attach integration, it will give me that same thing from before, where I can select the serverless function, and then I can click attach integration, which is a little bit off, a little bit hidden by my face there. Okay, so this, I think this is pretty much it. Let's go ahead and test this out. So back in VS Code, I'm going to open up our test.htp file. I think we're done with the rest of these, so we can close all those out. And then let's go ahead and add those 3 hash marks. We will do put HTTPS. Instead, I'm going to copy this whole URL again, so I don't have to type this thing out. And since we know the last hotel that was created in the database had an ID of 3, so let's work off of that and let's update the hotel of ID of 3. So we can copy all of this down here from our post command. Since we're still going to be sending JavaScript or JSON, we're still going to be using the same structure that we did from the post request. I'm simply going to update some of these values. So we'll do Orca Sun Life results Aqua. I don't know. It was an aquatic center, I think I saw. And then let's just do Turkey. I think I saw this was in. And bump this up to 4.3. Okay, so just to show this, let's go ahead and send the GET request again. So this is the GET. We can see this is the original value that was sent in with the post request. Let's go ahead and click this put request. And we got a 200 of OK. Let me send the GET again. And we can see the values inside of the database were updated. For extra measure, let's go. One second. I want to double check this before I click on things. Okay, so I don't have the. I wanted to make sure I didn't still have the connection details up on my database here. So if I go to console, and if I do select star from hotels, just to demonstrate, there's that third row that wasn't present in the database beforehand. So we know that this is the data is getting to the database, which is pretty evident from the API response, but I figured it'd be worthwhile just showing it inside of the database itself. Okay, so the put was working properly, and then last thing we'll do is we will do a delete. Pass in the delete method name there, and we're not passing any body back down, so we literally can just take this entire URL with the hotel ID of 3 and paste it in there. Save that, and we'll run it. We got a 200 OK response. If I query the API again, we only get the first 2 hotels that we created. And then lastly, let's go back into PlanetScale, and let's run this select query again. So select star from hotels, and it's only the first 2 hotels that we created. So there you have it. That is kind of the gist of everything. That's the gist of using the serverless driver for JavaScript. Hope you enjoyed the stream. This is going to kind of conclude where we're at right now. The last thing I have to do is drop in a link in the chat. Everybody keep an eye on that. This is for those 5 free hats. Go ahead and paste that and go. First 5 people that can get in there get a free hat. Let's see here. Got someone says that's neat. Very cool. Awesome. Glad you all enjoyed it. Yeah, any questions? Yes, the link is first come, first serve. James says nice swipe transitions. I'm using Streamlabs OBS. Yeah, it's custom pack. So we're working on some stuff. So already got mine. Yeah. So yeah, if you're interested in learning more about this, I'm actually also going to drop in a link to our documentation site here. This is one of the best places to go to get started. As I've said, this kind of walks through the reasons why you'd want to use this, how to use it in a kind of a generic sense, how to implement it into your own project, as well as there is an example that's there built with Node.js and using Express. You can actually pull this down to your local machine and run it without having to use a cloud provider just to get some practice with it. But with that, I'm going to go ahead and sign off here. I hope you all enjoyed the stream, and I will catch you in the next one. Thanks. Bye-bye.